section, we're going to talk about parent functions. In the next one, we're going to be graphing more functions using these parent functions. So it's important that you understand what they look like in their general sense. We're going to start out and talk about linear functions, but I wanted to start talking about two special ones. And the first one is a constant function. And that is literally that the function equals a number. So f of x, remember that's our function notation, equals c. So we have is a graph, our x and y axis, and you have wherever c happens to be. So that's our graph of f of x equal to c. That is a horizontal line. What happens is all the values stay the same or stay constant along that line. I'm going to use my line to make it a little bit straighter. So all of the numbers, or the outputs, stay the same. The next one that we're going to talk about is the identity. The identity is the function f of x equals x. And remember, f of x is the same as y, so we have the xy axis. What we have is a line that's y equals x. Another way of looking at that one. So if you were to look at a table, all of your values are the same. Meaning your input equals your output. So 1, 1, 2, 2, 3, 3, and so on. Whereas back here at the constant, change colors. 1, it's C or whatever happens to be for C, 2 is the value of C, 3 is the value of C, and so on. A linear function in its general form stuff a little bit of room here, is mx plus b. So b is that y-intercept, and m is the slope. So it looks something like that. It would look like this if it was a positive slope. It'll go down from left to right if it's a negative slope. And that order pair that they're crossing is your y-intercept. So m is the slope, b is the y-intercept. Now that should all be some review for you. You might not have heard the function called a parent function before, and you might not have been, like the y equals 2 might not have been called constant before, but those are review graphs. The first thing that we're going to do is write the equation for the linear function. We will be using point slope form. And that is crossing through a point, it's y minus the y coordinate equal to the slope times x minus the x coordinate. We will also switch to slope-intercept form so you can have a sense of how to do that, but we're going to start out with point slope. So in order to do that, basically what we have here is two ordered pairs. It's going to plug in a 1, I get back a 4. When I plug in a 2, I get back a 7. So to review, slope is rise, which is subtract the y's, over run, subtract x's. So slope is 3. So your answers could be y minus the y coordinate equal to the slope times x minus the x coordinate, or y minus the y coordinate equal to the slope times x minus the x coordinate for that second point. So we have one over a pair of 1, 4, and the other one 2, 7. Now you could also do slope-intercept form in your traditional way. I'm actually going to take and do slope-intercept with this last one, so I'm going to switch colors here. So if I distribute the 3, don't forget to distribute to both of those, and then add 7 to both sides. So this one is in slope intercept form. So to sketch a graph of these, remember, this one you could do a couple of things. We know we have the point 1, 4, and 2, 7. So you can use those two and graph your line that goes through those 2 points. Your other option, remember this is review from Algebra 2, so if it seems we're going quickly, that is why I'm putting it so quickly. However, if you still maybe don't remember it quite well, you should come in and get some help on those. So you can also use the y-intercept, which is 0, 1, and use the slope up 3 over 1. You could also make a table, XY table. So those are all some review. Also, make sure you know how to graph these on your calculator. Just put it into your y equals. Okay, a couple more functions. The first one I want to talk about is a quadratic, or sometimes your book calls it a squaring function. These will look like that. So it's f of x equals x squared. If you need a table, you can have negative 1, 1, 0, 0, 1, 1, 2, 4, etc. The domain of these are all reals. The range is all reals that are greater than 0, so from 0 and up. The function is symmetric about the y-axis, so if I were to fold on that y-axis, it would match up. It's decreasing from negative infinity to 0, and it's increasing from 0 to infinity. There's that minimum at 0, 0. It has x-intercept of 0 and a y-intercept of 0. And it's also an even function. So all kinds of things about our quadratic. The other one is a cubic, which looks kind of like a sideways S. Domain is all reals, range is all reals. The x and y-intercept are both at 0 again. It is increasing the entire time. It is symmetric about the origin, so that's kind of like that two-folder. So if I fold along the x-axis and fold along the y-axis, it will be matching up with the origin. And it is an odd function. About the one, opposite value. These are nice, pretty leaves. Your calculator will graph absolute values. If you go to y equals, you're in your y equals, and then push math menu, go to the right where it's num, N-U-M, And the very first one is A, B, S, and then the parentheses will serve as your absolute value signs. I don't have the calculator to show you that, and I apologize for that. I am happy to show you if you do come in. Square root function looks like this. Now, I'll talk about square root for a minute. So if you were to do square root of 4, you would normally say plus or minus 2. But remember, to be a function, it has to pass that vertical line test, which means each x has only one y. So that's why to make it a function, it is only that part. This one, the domain are all the values greater than or equal to 0. Same with the range, it's greater than or equal to 0. It has x and y intercept, again at 0. And it's increasing the entire time. And it's not, it does not have any symmetry to it. The reciprocal function has asymptotes, and I'm not sure your book draw these in. There should be dash, I'm just going to make them dash as much as possible. It looks like that and that. The domain is all reals except for 0. Same with the range, all reals except for 0. Both of those have asymptotes. It is an odd function. It's decreasing from negative infinity up to 0 and 0 to infinity. Make sure you recognize that domain. If I fold it along the x and then again on the y, it's symmetric, so it's symmetric about the origin. And it is an odd function. Now, one that you might not have heard about before is the greatest integer. So I'm actually going to write it down and talk about this one a little bit more in depth. That cool symbol. So if our function, so if I were to do 0, the greatest integer is 0. If I do 0.2, the greatest integer is 0. If I do 0.7, the greatest integer is still 0. So what you're doing with these is truncating the number, so you're just like cutting off the decimal. So like 1.1 is 1, 1.9 is 1, 3.7 is 3, get the idea. So these, what the graph looks like, at 0, it's 0, all the way up to 1. So then 1, or 0.9999999, etc. is all still 0. Starting at 1, it's 1 again. Kind of looks like stair steps, and you're calling step functions. So that's what the graph looks like, and it continues on in the same pattern for the whole thing. The domain does end up being all reals. So right here, this closed circle, we're filling that open circle. The range is the set of all the integers. So 0, 1, 2, 3, negative 1, negative 2, negative 3, and so on. The x-intercept is at 0, and the y-intercept is also 0. It doesn't have any symmetry, so it's not going to match up exactly. It kind of looks like it would, but remember these open circles should match up, and that's what kind of cuts off that origin not matching up. And it's not, the other thing we're talking about is increase and decrease. They're staying constant on all of those steps, so it's not an increasing or decreasing. So those are all of your parent functions. One thing we're going to be doing is what's called piecewise functions. I'll move yours up. So what a piecewise does is it puts functions together. Now, you would have already evaluated these in a previous section, but we'll do it again when we graph it. Actually, so we can make it the next one. I'll get a piece of graph paper here. So what you have going on is we basically have two lines. So that's a good practice. For graphing equations, we have our linear equation, x minus 4. And that is true for all the values of 1, or lower than 1, I should say. So 1, 0, lower than 1, negative 1, negative 2. I'm going to include that 1 and we'll talk about the 1, but for right now, if I substitute 1 into it, 1 minus 4 is negative 3. 0 minus 4 is negative 4, negative 1 minus 4 is negative 5, and negative 2 is negative 6. So when I graph these, 4, 5, 6, so what happens here, because of the less than symbol, this should be an open circle. So our line looks like this. And it goes on forever in the left direction, or decreasing. And then our second part of our graph is the x squared minus 1. And x is greater than or equal to 1. So when we see this one, we know, oh, well, it's quadratic, so it should be a U-shape, or a squaring function. We call it a squaring function. Quadratic. So, starting at 1 and up, 1, 2, 3, 4. Probably won't be able to graph all those. So 1 squared minus 1 is 0. 2 squared minus 1 is 3. 3 squared minus 1 is 8. And 4 squared minus 1 is 15. So I have 1, 0. And that one is a filled-in circle. Bigger and bold up. So 2, 3, 3, 8, and then the other one's off the chart. This would actually be that is curving up to try to make it as curved as possible. Another way of graphing these is to graph the line, just draw it over the top. So imagine that I graph, this is x minus 4, and graph the parabola. Graph the two, and then go and erase. So the parabola is when x is greater than or equal to 1, so erase that part. And the x minus minus 4 is only true for 1 and below, so erase that part. So it's another way of graphing your piecewise functions. Your calculator will graph those as well. It does have a strange syntax. If you'd like to see how they graph them on your calculator, please stop by and see me. Although you're going to need to know how to do these without your calculator, so I won't take your time to do that today, but it's a good way to check them as well.